Hello everyone, it's Mr. Wolf here, and I'm going to be going over number 1, explanations on the formative. So for this problem, Mr. Ehrman is pushing a box to the left, all right? And then it tells us a little bit of information about our forces. All right? So I'm going to start drawing my FBD right here. Am I on Earth? Yes. Force of gravity. Is there like a cable? No, so no force of tension. Is there a surface? Yes, so my normal force going up. And let's see, he's pushing it to the left. So if that's the case, he's moving it to the left, pushing it to the left. So I'm going to have, is there an object in contact or a person in contact that's pushing it? Yeah, his force push going this way. All right. And it's on a rough surface, and it's causing a force of friction to be a friction, and that causes a force of friction, and that Mr. Ehrman's push force is less than the force of friction. So my force of friction is going to be greater. Remember, the force of friction always goes against the intended motion. Intended motion's left, so force of friction right here. All right. I'm eventually going to get to the equations on the LT5A, but this is just explanation, so we don't need these right now. All right. And I'm not going to get to these just yet because we're about to reason through them. All right. Now, it's asking as Mr. Ehrman pushes the box, what's going to happen? I don't need to necessarily make my claim yet. All right. But I'm going to start off with what I know, all right? And out of acceleration, net force, relevant forces, and velocity, I know the relevant forces, all right? Specifically, I know that the force of friction is greater, all right, than the push force. All right. Now, by the way, also at the end of the day, the claim's about velocity, so I'm just going to write here velocity because I know that I want to end my claim here, all right? And so let's see, force of friction is greater than the force push. So then what do I automatically know? I'm going to use my physics concepts and know that relevant forces cause net force. So if my force of friction is greater than my push force, then my net force is to the right. And if I know my net force is to the right, that also means that my acceleration has to be to the right. So then my acceleration's to the right, but then I also need to know what's the initial velocity, right? Because if the initial velocity is going to like a different way, I could have a completely different speed. It tells us here that Mr. Ehrman's initial velocity, right, is to the left. And I know that my acceleration is in the opposite direction to the right. And whenever we have velocity and acceleration opposing one another, then we're decreasing speed. So because initial velocity left and acceleration is opposing it, then the box will decrease speed. All right. And then boom, speed is the same thing, velocity. I've ended right where I wanted to. All right. So not only do the physics concepts have to be correct, so physics concept is like saying that force is to the right, acceleration is to the right, that the object's going to decrease speed, talking about relevant forces, but we need cause and effect. That relevant forces cause net force, that net force causes acceleration, and acceleration and initial velocity cause the velocity to be what it is here.